Is it on? Yeah. Alright, morning class. Jace, Bunky, how are you?
Gard.
Right, today we're going to work on a little bit more work on simple fractions. So last week we did simple fractions where we combined 1/4 and 1/4 to know we had 2/4. Okay, this week we're going to do equivalent fractions. So I've got you a few pieces of a pie, effectively, all different sized fractions, and I want to see if you can make a number of different whole shapes, so where they add up to 1. So I want you to make one circle. Very nice. Oh, good one, Jace.
That's right.
What about you, Bunky? You gonna do anything, mate?
No, it's too tired.
This is one of them.
There we go.
So you've got some interesting shapes there. So we're going to make sure that these ones equal 1, and we're going to see how we go. So with your first one, press the blue button, click on my interactive whiteboard that I purchased for this especially. So we got 1/2. I'm going to have a 1/4. And from last lesson we know that when we have 2 1/8, that is in fact 2/8. So we know that from last lesson. Alright, so I might now press the old green button. Alright, we need to add these together to see whether we can equal 1. What we need to do is we need to get the denominator, the bottom line, to all be the same. So we can add the top line like we did in simple fractions last lesson. So Jason, or Bunky, put your hand up. What do we need to do to the 2 to get it to equal 8? Yep, Bunky? Yep, you can speak now, Bunk. Oh, multiply it by 4. Very good. Alright, so I'll multiply that by 4. Now I'll tell you why in a minute, but we need to do the same to the top as we do to the bottom. So we're going to multiply the top by 4 as well. Okay, on the second one, how do we get this 4 to equal 8? Jace? Multiply by 2. Very good. Multiply that by 2, and as before, we'll do the same to the top. And we can leave the last one. So we now have 4/8 plus 2/8 plus 2/8. And from last lesson, we know that that is 8/8, which is the same as 1. Very good. So that's 1 whole. Now, next one. That was very good. So get the blue button back up. What do we have? We had 1/2, and we had 1/5 plus 1/6 plus 1/8. Alright. Now this one's a little bit tricky. I have pre-arranged this one, believe it or not. It's the green button. Alright, so we need to find the lowest common multiple. So 2 will go into 6 and 8, but 6 will not go evenly into 8. Neither will 5. So we need to find the lowest common multiple so we can divide this, what we think is a whole, into even-sized pieces. Okay, so looks like it should be 120. So we want all of these to be over 120. So what do we need to do to the top one, or the first one, to the bottom line to get it to equal 120, Jason? Multiply it by 60. Very good. So again, we'll do it to the top and bottom, and I'll tell you why like I should have before. Same for this one. This one will be 24 20, 20, and 15. Alright, and like before, we've got 60 plus 24 over 120. 20. Stop talking, Bunky. Keep going. And 15 over 120. And when we add these, yep, bottom line's 120, and the top line is in fact 119. So it's almost a whole, but not quite. So, I mean, while this looks like a full circle, it is in fact only 119 120ths. So just press next. Now the reason that we can multiply the bottom line by 60, and the reason we have to then do the same to the top line, let me just get my blue pen, is because when we multiply the top line and the bottom line by 60, we in fact are multiplying it by 60 over 60. And Bunky, what does 60 over 60 equal? Yeah, that's right, 1. So when we multiply a number by 1, we don't in fact change it. The number is still the same. We've just changed the numbers on the top and the bottom. The overall number is still the same. Okay. Alright, next slide. Okay, before I set you on some coursework, Bunky, we're going to do a little bit on simplifying. Alright, so on my interactive whiteboard I already have this set up. We've got a fraction of 16 over 48. So we have 16 little 48ths of a circle. How are we going to work out what that really is? Because that's a bit hard to get your head around. 16 48ths. How big's a 48th? Okay, so we need to simplify this number. So like before, we're now, instead of multiplying out the bottom line, we're actually going to divide. We're going to try and find the highest common factor that will in fact fit into both 16 and 48. So, is there a number, any number, that can be divided into 16 and 48 evenly? Jace? Any number? What can we divide 16 by? But we can also divide 48 by.
8.
8, yeah.
Divide by 7.
Or even, yeah, 8. That's jumping the gun a little bit, but thanks anyway.
Sorry, mate.
So we have, therefore, 2 on the top line and 6 on the bottom line. Alright, so what can we now do to the top line and the bottom line? What can we divide both of them by?
2.
2. Very good. And 2. Pen's breaking. And that, of course, equals 1/3, or 1 over 3. Now, to make sure that 16 48ths actually does equal 1/3, I'm going to just slide down my screen. Oh, there we go. I'm going to get green pen out. Alright, now we've got a little grid of 48 little squares, all theoretically the same size because I've done this on computer. Now we're going to get 16 of these. So we're going to, alright, there's 16 48s. Now I've got the black pen. Let's see if that in fact equals 1/3. So we want to divide this shape into 3 equal bits. So, got 1 piece, 2 even pieces, 3 even pieces. And as we can see, our 16 48ths does in fact fill 1/3. Alright, so before I set you on your work, please turn your phone off in class. We're now just going to go on with the exercises, and we've just got to remember that whatever we do to the top we must do to the bottom, because this is exactly the same as before. It's 8 over 8, so we're in fact dividing this whole number, theoretically, by 1. So we can do it. It's not going to change the number. Alright, Bunky, get to work, mate. Thanks.